In this video, I'm going to show you how to find the correlation coefficient between two variables and to test whether there is a significant correlation between the variables. And finally, we are going to use Excel to find the equation of the regression line. The data here represent the tar and nicotine contents for 29 different brands of cigarettes. Remember that we're always testing the null hypothesis, that rho equals 0, which means there is no correlation, against the alternate hypothesis that rho is not equal to 0, which means there is a correlation. As always, we need a test statistic, and our test statistic in this case is going to be the correlation coefficient R between the variables. So R we find by typing equal correl, C-O-R-R-E-L, and then we just choose our two data arrays. And remember, it doesn't matter. We're going to put the first data array and then a comma and then the second. And it doesn't matter which one we put first and which one we put second. This will not affect our correlation coefficient. All right, so we got a correlation coefficient of 0.961. We'll round that to 3 decimal places since that is the standard rounding for correlation coefficients. And then the next thing we need is our critical value, our R sub alpha, so to speak. And we have to decide on a level of significance. So let's say we want to be 99% confident. Okay, so that would mean we have a level of significance alpha of 0.01. So to find the critical value, we are going to use the table from Triola textbook here, table A6. And remember, we have to find N, which is our number of pairs of data. We had 29 different brands of cigarettes, and our alpha was 0.01. So if we scroll on down here, we see that in this table, we don't have the value 29. So we will use the more conservative of the lesser of the two values, which is 25, and we see that we have a critical value here of 0.505. So we will go back over here and we will say that our critical value is 0.505. All right, so remember that our criteria for rejecting the null hypothesis is if our test statistic R in absolute value is greater than our critical value. And we see here that R is indeed greater than our critical value. So we will reject the null hypothesis. And that means there is sufficient evidence to conclude there is a correlation between tar content and nicotine content. All right, so now once we know that there is a correlation, we can find the equation of the regression line. And the easiest way to do this is to actually just highlight the data, and we will insert a scatter plot. So we'll go to Insert, we'll choose the scatter plot drop down, and we'll choose the first one where we have the points only. So when we look at the chart, we can see that there definitely appears to be a linear correlation, positive linear correlation. All right, so remember, to find the equation of the regression line, we simply choose any one of these dots and right-click and say Add Trend Line. And the trend line properties box displays, and we will put Display Equation on Chart. And now we have our regression equation. Y is equal to 0.0651x plus 0.154. So there's our regression equation. And now, since we know that there is a linear correlation, we can actually use our regression equation to predict our dependent variable based on our independent variable. And since I chose the nicotine as the second variable, I will call that the dependent variable. So let's find out how much nicotine there is in a cigarette that has 10 units of tar. Okay, so since we do have a strong correlation, we will use the regression equation, and we will simply plug in 10 for x, and we would find that y will equal 0.0651 times 10 plus 0.154. Okay, so again, we're just plugging 10 into our regression equation here in place of x, and this should give us a prediction for the amount of nicotine, which would be about 0.805. Now, if there were no correlation between the two variables, then we would use the mean of the y's as our predictor. Okay, so the mean of the y's would be found by taking equal average, and then we would just average our y values. So the mean amount of nicotine is 0.941, but we would not use this as a predictor unless there was no correlation. So the best predicted value for the amount of nicotine in a cigarette with 10 units of tar would be 0.805.